Hey guys, it's Mr. Vrandrick here. Welcome back. I know you've missed these videos. Here we are with our Period 7 Blue class talking about systems of linear inequalities. So we're going to be doing a lot of shading today. So if you want to follow along with the notes at home, make sure you take out some different colored pencils or pens if you'd like to do that, right? Time to shine. So let's do this. Here we go. The first one is in slope-intercept form. What's the y-intercept of the first one? Positive 1, right? Positive 1 right here. So I'm going to go on to the y-axis where it says positive 1 and put a point. What is the slope of this line? It's actually 1, right? Slope is never the variable. The number in front is 1. It's not there. So 1 over 1. So up 1 and then to the right 1. Put a point. And then down 1, left 1. Now you should have a ruler at your desk. So go ahead and make your line. Now be careful today, because today we have to check to make sure if it's going to be a solid line or a dotted line. So in this case, it is solid. So just be careful today. Okay. Now, it is my preference to wait until the end to shade. It's my preference. But those of you that have, especially that have different colors out, feel free right now to shade. But we have to figure out, where do we shade for less than? Below the line. Below the line. So personally, me, I just write an arrow that I'm going to shade below. But if you have a color and you like to use it, please shade below the line with your color. We're shading below the line because it says less than. Below. Greater than would have been above. All right, so now you should have shaded or not and put this little arrow that says I'm going to shade that way. If you'd like to, I always use 0, 0. Right, so 0, 0, 0 is less than or equal to 0 plus 1. So is 0 less than or equal to 1? Yes, so 0, 0 is a part of my shaded area. So I'm shading below. You can always do that if you're having trouble. Now let's look at the next one. Oh, the next one doesn't have an x. So that means it has no slope. So I go to my y-intercept at 2, and what kind of line am I putting through that? No, Frank. Horizontal. Good little switch there, Kylie. Horizontal. Now be careful. It needs to be a dotted horizontal line. With your ruler, make a dotted horizontal line. Yep. Correct. Whenever it's y and a number, Leslie, it's always going to be a horizontal line. Mine was dotted or dash, yes. Now, what is the inequality symbol with that second one? Greater than. So we're going to shade above the line. In this case, above the line. So if you're using another color, use your other color and shade above that horizontal line. And when you've shaded with your two colors, you will see where the solution area is. Where they overlap, nope, that would definitely be not the answer. Where they overlap is the answer. So I'm going to use a different color to shade my answer. Use blue. So where they overlap is here. Now, does anyone know what this means? Does anyone know what this means? Because, I mean, yes, it's the answer to graphing this, but does anybody know anything about this blue area that I just shaded? Any point that's what? Any point that's in this blue area is going to make this system true. It's going to make both of them true statements. So let's say you plugged in a point in this area. If you plugged in a point in this area below that first line, you're going to make the first one true, but not the second one. If you plugged in a point in this area over here, you're going to make the second one true, but not the first. So only points in the blue area are going to make both true. All right? Everybody good on that? Yes. Yeah. Mm-hmm. Are you talking about for the second one? So is 0 greater than 2? No. So I would not be shading down from that horizontal line because that's where 0, 0 is. I'm shading above. Well, that's we were for the second one, yes. We're going for both, right? Are you using 2 colors? So you have 2 colors. I got you. Ready? Okay. So 2 colors. I'll use blue for this one. Okay, so there's my first color. Yes? Okay. Then let's use, I don't know, red for this one. Do you see where the blue and the red, sad. Do you see where the blue and the red both are? That's my solution area. So any points in that area where they overlap would make my system true.
Oh, got it.
Now again, my preference is to do what I showed you, where I don't use, is this yours? Oh. Where I don't shade until the end. That's my preference. Clarissa?
The graph itself?
Yeah, it just says to graph it, but if I asked another question, Clarissa, give me a point that would make this system true, then I would pick a point, I don't know, like, let's see, think like 10, 6, 2, 4, 6, 8, 10, something like, I think it's like a here, that's 10, 6, that's in that area, so it's going to be one of infinite solutions for this system. Right? I know that my grid stops, so I stop shading, but you guys know these arrows are going on forever, so that area that's the solution area is going on forever. Okay. Everybody good? Excellent. Let's do another one.
Wow.
Let's try this one. What do you notice about this system? They're both already in slope-intercept form. Great. Anything else you notice? Just fun. Ooh, Genesis, what is this, Elena? The same slope but a different y-intercept, which means they're parallel lines. Now, if this had said equals for both of them, I would know right away they're never going to touch, so there's not going to be a solution. This system would be an inconsistent system. What up, vocab you'll need for next week? Okay, but it has inequality symbols, so maybe it'll work out. So, the first one, the y-intercept is -3. The y-intercept is -3. So I'm plotting on the y-axis my y-intercept of -3. What's the slope of that first one? 2/1, a positive. So I'm going up 2, right 1. Down 2, left 1. What kind of line am I going to draw? A dotted line, right? Neither of these say or equal to. All right, so once you have that, if you're using multiple colors, now you can pick a color to shade. What direction should I shade for less than? Below. So below is going to be this way, below the line. So I put my arrow there to show which way to shade. So if you're using colors, go ahead and shade below that line. Again, if you want to use colors on the test, feel free to use colors on the test. That's fine. I will allow it. But you must BYOC. Bring your own colors.
Oh, man.
All right. Now, let's do the other one. The other one has a y-intercept of +2. So on the y-axis, I'm going to +2. It has a slope of 2/1, just like the last one. They're parallel lines. So same thing, up 2, right 1. And you will see that this is parallel to that first one we just graphed. Now we know they never touch, but maybe their shaded areas will overlap, and we might actually get a solution for this system. But when you look at that inequality symbol for the second one, it says greater than. And greater than is above the line. So sadly, especially if you're using 2 colors, you'll see that will these shaded areas ever overlap? No, so this one actually does not have a solution. Now, I want to be very clear here. It didn't have a solution because the shaded areas didn't overlap. All right, not because they were parallel. All right, so I'm going to show you here in a second, especially those that are still working, I want to show you what would have happened if I had changed the inequality signs. So what if I had said y is greater than 2x minus 3 and y is less than 2x plus 2? Then, for this first line, I would have shaded above. And for the second line, I would have shaded below. So it would be everything in the middle would have been the solution. Now that's not the answer, so you don't need to write this down. But I'm saying just be careful. Because they are parallel, don't think, oh, it's automatically going to be no solution. If I have the inequality symbols set up in that way, it might actually be in between them is the solution. Leslie? That's the solution area. So if it doesn't say anything else besides what I'm telling you right here, you're done with, like, remember this one? Where is it? Like this one was done. But if I ask, Alonso, could you give me an ordered pair that is a solution to this system? Then you need to pick an ordered pair that's in the solution area. Okay? So I picked 10, 6. That's not the only one you could have picked. But that one is in the area where they're both overlapping. Okay? Now on this one, Alonso, they don't overlap. So there is no solution. But if I change the signs, then I would pick something in the middle, like 0, 0 would have made this system true. Okay? Let's do one more together. Now, I'm just going to tell you, I'm going to be honest with you. If you've been using colors, which I see a lot of students have been using colors, which is great, I'm going to encourage you not to use colors on this one. Do you see how there's 4 of them? You're going to have a lot going on, and I think it's just going to confuse you. All right, so I would encourage you not. If you're like, I want to be a rebel, that's fine. All right, you can use your colors. I'm not going to say don't do it, but I'm going to encourage you, don't do it. Okay, don't do it. Oh, Andres, she's thinking she might do it. I can see it. All right, so let's look at the first one in this system. The first one in this system only says x and a number. Do you remember what happened when we had y and a number? It was, all lines are straight, it was horizontal, right? So what is it going to look like for x and number? Vertical. So go to the x-axis to -2 and do a solid vertical line. Come on, so you can do this. Yes, question? I'm doing the first one. So I went to x-axis where it's -2. And I put a vertical line through that point. The reason I did that, Alondra, is because all of the points on this line have an x value of -2. So anytime you see x and a number, it should be a vertical line. Every time. Okay, so here, where would we shade it, right? I wouldn't shade it, but where would I draw the arrow to shade? It says greater than. And I told you greater than is above. But there's no above or below this line. So what do you think I'm going to shade for greater than -2? To the right, because these numbers are greater than -2, right? -1, 0, 1, 2. So I'm going to put an arrow to shade that way. You could also plug in 0, 0. You'd only be plugging in the x value of 0. Is 0 greater than or equal to -2? Yes. So you'd be shading that one. That's another way to do it. Okay, the next one. The next one is that horizontal line at the y-intercept of 1. So I'm going to put a horizontal solid line at 1. What's up, Anthony? It's about to get fun, right? I mean, it's been fun, let's just be honest. Maybe one person will watch this video. Okay, so it says less than 1. So what am I going to shade for less than 1? Below. So I'm going to put an arrow to shade below. So right now, if this was done, if these were my only two linear inequalities in this system, my solution area would be this bottom right portion. If it was only two, but it's not, Josue. There's two more. They're all or equal to, right? So they're all solid lines? Okay, the next one has slope-intercept form. So I'm going to go to -2 on the y-axis, put a dot. Now I know the slope says 0.5. I'm not going to go up 0.5 and write 1. I'm just going to use that as 1/2, because 1/2 is 0.5. So I'm going to go up 1, right 2.
Do we do that whenever we get decimal?
Please.
Yeah.
Please. Oh, sad. Oh, no. It just closed it. Wait. Are we okay? Okay, we're kind of okay. I lost that line. Oh, man. I thought I was going to have to stop the recording. Start over again. Woo! That was close. Yeah, I would have. I would have done a different class. I know, right, Alonzo? That you would not be on this video. I did, right? All those people are going to watch and hear your name. What's wrong, Frank?
Why are you calling out my name, Anthony?
Okay, so after you graph this one, it says greater than. Greater than is above that line. So if it was done at this point with these three, what would my shaded area be? What is it? No, what is it? So I see it. What is it? Yeah, what is it? It's a triangle. That's right, that's Alonzo, right? Okay, good job. Good job, Alonzo. Now, we're not done, though. We're not done. There's one more. I know, Maddie. One more. Y is less than or equal to -2x plus 3. So I'm going on the y-axis to +3. And this time, the slope is -2. So I'm going up 2 and then left 1. I am going to go down 2 and then right 1. And make a solid line. Okay? I'll let you catch up there before we finish. That's why on these, Josue, when there's more than 2 linear inequalities, I tell students don't shade until the end. Now that one says less than. So I'm going to be shading below. So that's below the line, which is there. And if you see, it's actually not very large anymore, that shaded area. It's going to be right in here. It's not a triangle anymore. It's not a square.
It's a right triangle.
Don't know why you keep saying triangle, right? We said it's not 3-sided.
It's a kite.
It's a rhombus.
Now, considering we don't know, because people keep saying different things, so what is the one that we definitely can say because it has 4 sides?
Square.
No.
Rectangle.
No.
Square.
Somebody said it. You said it? It's a quadrilateral. Quadrilateral has 4 sides. You want to go any further than that, you'd be able to prove it, right? You say square needs all the sides of the same length, and they need to be perpendicular and parallel, and that's not happening here.
Okay.
See, Alondra did it. Alondra decided to use all of the colors, and it looks like a mess, right? A colorful mess, but still a mess. So I would recommend, Alondra, to just use the very last one. But then you can, how about this? When you do it, then make this one rainbow colored. How about that, right? Best of both worlds. You get the best of both worlds. You just lost. I just lost a subscriber, Frank. You know what? It felt right. Okay. Here's what you're gonna do. All right. You're gonna do the